understanding how health and defense works.
We must give thanks to Everything Rock, which has helped a lot in terms of understanding how some of these formulas and calculations work.
In this section, we will be following the basic calculations that determine how attack, defense, and health are used in a fight. We will not be covering the counterattack or balance variable, which is seen in the final calculation, as this section serves to outline the importance of defense and health in resisting attacks. For those interested, the final formula looks like this. Damage of multiple troops. The total damage applied to the defender is calculated based on 3 separate parts. Number 1, the total march size of the attacker. As we spoke about earlier, march size correlates to increased damage. Number 2, total attack stat. So this is the base attack stat of the march plus all attack bonuses of the attacker. Number 3, this is then divided against the enemy's total defense stat. This then will give us how much damage in this one turn the attacker can apply onto the defender. So by looking at this equation, all the top values, so the ones above the division line, correspond to the attacker. Anything below the division line here is related to the defender. Troop losses. Troop losses tell us how many troops will die from the damage calculated in the previous calculation. So the damage factor 100 is the total damage after all variables of the previous formula have been taken into account. In other words, the total damage inflicted after we've accounted for the defender's defense stat. This is then divided by the defender's total health stat. So this is where we now start to have a relationship between defense and health. So you can now appreciate from the 2 formulas, so the one we've just covered now and the one previous to that, how important defense and health are in resisting an enemy's attack. We can summarize the 2 formulas into one. So we can combine the 2 equations to summarize the events per term of combat with the first formula above the division line and then divided by the enemy total health stat. Well, we can also simplify that further. We can have the damage factor 100, which is output of the first equation, divided by the enemy's total defense health stat multiplied by the enemy's total defense stat. Now let's visualize this. Because both health and defense are used as a denominator in the formula, the more health or defense you have equates to less troop loss. So in mathematical terms, the larger your denominator is, you're always going to have a smaller answer. So in this case, you're going to always have a smaller amount of troops lost. We can use a couple of examples to show why you should always have defense and health at an equal value. So as both health and defense are used as a denominator, we can multiply this to show the level of evasion from a single attack from your attacker. The higher the value, the better, as this means you can evade more damage. So let's have a look at health and defense, and we will say that we do not want the values of health or defense as individuals to exceed a total of 100. So both values should make up 100. So let's say health is 50 and defense is 50. So in total they equal to 100. But let's multiply these. So 50 multiplied by 50 equals 2,500. So 2,500 is what we will call the evasion variable. Now let's say health is 40 and defense is 60. Remember, they total up to 100 if we were to add them together. So when we multiply these, so 40 multiplied by 60, we get an evasion variable of 2,400. So you can see already this is 100 lower than the previous one. But let's have a look at another example as well. So let's say defense is 80 and health is 20, or vice versa. When we multiply these, 80 multiplied by 20, we get an evasion variable of 1600. So you can see if we dramatically increase one of either stat and the other is quite low, the evasion variable does come out lower. But as you saw when we did 50 multiplied by 50, we got 2500 as our evasion variable. That was a much higher value. So try making up your own total damage number and inputting the following combination of health and defense into the formula to show that having defense and health at an equal level brings about the best return. If we do not consider it as a percentage and both defense and health are not required to total up to 100, we can still see that having health and defense at an equal level brings better returns. For example, say health is 50 and defense is 100. When we multiply this, so 50 multiplied by 100, we get an evasion variable of 5000. Say we increase health by 20 to give us 70. Let's see how this affects the calculation. So 70 multiplied by 100 equals 7000 as an evasion variable. Now instead, let's increase the value of defense by 20 to give us 120 and see how this affects the calculation. So 50 multiplied by 120 equals 6000. We can see increasing the lower stat increases the amount of damage we can evade. The closer we can bring defense and health together, the more damage we can evade, which translates as less troop deaths and troop losses. In conclusion, you should try to buff the weakest of the two stats, defense or health, because the optimal value is obtained when health equals defense. But as you know from the game, health is always the lowest stat, and that's why you will always hear a lot of content creators and other individuals recommending that you should always boost your health. Obviously, as well as this, it is circumstantial.